Is there a definite edge to the universe? And is it possible to go on a one-way space journey until we reach that edge? It might be like the movie The Truman Show, where astronauts encounter a fake background decorated with painted stars. On a more serious note, scientists don't think in terms of clearly delineated boundaries of the universe. In reality, what we observe with modern telescopes constitutes only the observable universe. The generally accepted boundaries of this observable universe extend about 14 billion light-years from Earth, which coincides with where the Big Bang occurred, according to popular theory. Nevertheless, if we were able to look beyond this boundary, we would likely see a celestial panorama much like the one we see today: galaxies, star clusters, and black holes. However, this view is not universally accepted. So where to start looking for the edge of the universe? The answer lies in the realm of theoretical knowledge. For the outside observer, the universe has an unpleasant surprise in store. As we know, even the light from our sun takes about 8 minutes to reach us. When we observe another person or object, we see it a little bit in the past, as it was a few nanoseconds ago. Such a time delay is not impossible for celestial bodies in deep space. For example, our nearest neighbor, the Andromeda Galaxy, appears to us as it was 2.5 million years ago. It is logical to assume that the observed boundaries of the universe are also not visible in real time. The light captured by Earth's telescopes peering into the unfathomable depths is as old as the cosmos itself. The thought is jarring, but the objects whose photons have traveled millions of light years to reach us are likely long dead. Before the lenses of high-end telescopes, a universal graveyard unfolds. In this scenario, the observer unwittingly becomes a time traveler, which doesn't contradict the principles of Big Bang cosmology. The entire observable universe, roughly speaking, holds around 500 billion galaxies and is referred to as a metagalaxy. It spans 93 billion light-years in diameter and isn't stationary. Judging from its redshift, it's continuously expanding. So does the universe have an edge and what lies beyond the cosmological horizon. We are used to everything having boundaries and limits, but let's consider a donut or, for example, a basketball. Can anyone pinpoint exactly where they begin or end? Do these objects have boundaries or outlines? Indeed, they do, but there are no boundaries. If the universe is indeed shaped like a bagel or a sphere, then by traveling from point A to the hypothetical boundary of the universe, we will eventually return to the starting point. Now, let's do a mental experiment, best described by astronomer David Kipping. Suppose that mankind has managed to build a colossal spaceship with all the necessary resources and capabilities to travel to the edge of the universe. The crew of this spacecraft fear neither astonishing speeds nor enduring billions of years in space, even when faced with potential fatal collisions with microscopic dust particles. Let's assume the ship accelerates by 10 meters per second every second. Naturally, with each passing moment, the craft gains an additional 10 meters per second, gradually advancing to extraordinary velocities. If such a speed were achievable, it could reach the moon in a mere 2.5 hours. And a journey to Neptune would be completed in just 11 days. It would continue to accelerate, coming remarkably close to the speed of light. However, it's important to note that reaching the speed of light is unattainable, as well as for particles in the Large Hadron Collider, due to a set of laws prohibiting it. Yet, getting extremely close to the speed of 299,792,458 meters per second is within reach. This is when the effects of temporal anomalies begin to emerge, adhering to the initial principles of the special theory of relativity, where higher object speeds correspond to slower time passage. For the crew, time will run normally, according to the ship's onboard clock, and they will not notice anything unusual except for the acceleration occurring outside. At the same time, it will appear to an outside observer that the ship is no longer experiencing acceleration, but that the crew members have slowed down. A similar paradox can be observed when observing an object approaching the event horizon of a black hole. Time dilation is most pronounced when velocities of 90–95% of the speed of light are reached. But if we abstract from tedious calculations, the fact remains that even under such conditions, astronauts will not be able to observe any universal boundaries, since the rate of expansion of the universe is still far beyond their capabilities. However, it turns out that hard limits do not exist for everyone. Surprisingly, the concept of achievable speeds in the vacuum of space has been unexpectedly clarified by a particle known as the "Oh my God" particle. This remarkable event occurred in 1991 when a particle suddenly appeared on the screens of the fly's eye detector as an instantaneous flash. This particle was traveling at a speed billions of times faster than the bosons in the Large Hadron Collider. Naturally, in response to this extraordinary occurrence, scientists humorously invoked God as a witness and aptly named the particle the "Oh my God" particle. Its sudden appearance defied many of the fundamental laws and limits that physicists had previously held. Unsurprisingly, this event sparked numerous questions, with a prominent one being, what could have imparted such a tremendous acceleration to this particle? Many experts speculated that it might have been the result of the collapse of an enormously massive object or a supermassive black hole. There were even concerns that showers of such high-energy particles could induce irreversible changes in the human DNA chain. Regardless, the universe presented us with a challenge, demonstrating that in its vast expanse, nearly anything is possible. Analogously to our hypothetical spaceship journeying through the universe, time for the "Oh my God" particle slowed down by a factor of 300 billion, effectively coming to a near standstill. Even though, for an external observer, everything appears unchanged. For the shuttle's travelers, time would proceed at a regular pace, and they might experience a journey spanning several decades. However, from the perspective of an external observer, several million years would have elapsed. It's impossible to predict what might remain of our planet after such an extended period. When 200 years have passed for the crew, so much time might have elapsed in the universe that it could have entered a state of heat death, leaving the shuttle as the sole object in a profound, lightless void. Time itself would dissipate, as the ship's clocks would have nothing left to compare it to. This is because the Earth, the Milky Way, Andromeda, the Sloan Great Wall, and other vast cosmic structures might have ceased to exist. Worrying about the spaceship's astronauts returning home becomes a futile concern. Once they pass the 8.3 million light-year boundary, returning becomes impossible due to the expansion of the universe, which completely severs their causal connections to the solar system. This is the stark reality. Now, let's revisit the concept of the universe's boundaries. Do they truly exist? It's likely that the universe has an edge, but it's not a spatial boundary. It's a temporal one. This may seem unexpected. Notably, questions about the boundedness of the universe have been asked for centuries. Consider the Flammarion engraving, which portrays a missionary reaching the edge of the Earth and earnestly exploring the universe's structure. Just as people have speculated for ages about the appearance of potential alien neighbors, often projecting human qualities and appearances onto them through anthropological chauvinism, the same has occurred with the boundaries of the universe. We may have a desire to touch or glimpse something resembling a boundary, but it's improbable that we'll discover it. Do you know where it is? This elusive edge of the universe we seek. It's where time ceases to exist, and if time is extinguished, so is the universe. It might not be the answer you expected, but it's likely very close to reality. The universe perhaps only exists between the Big Bang and the Big Collapse. No more, no less. The mechanics of the singularity remains the great mystery of astrophysics, And it's not surprising, given that the cause and effect relationships of this phenomenon remain incomprehensible. Kip Thorne, the mind behind the legendary Interstellar, delves into the mechanics of the singularity in one of his books, advising us to look closely at black holes, among other things. The enigma of singularity points, where, as Kip Thorne suggests, space and time vanish, holds the secret. Nevertheless, not everyone acknowledges such boundaries for the universe. Some continue to seek the physical boundaries of our cosmos and imagine what lies beyond. For instance, proponents of a bounded universe propose that outside its limits, hypothetical extragalactic objects exist, governed by different fundamental constants. Yet, these are all hypotheses tied to unresolved issues in modern astrophysics. In summary, the problem of the universe's boundaries resembles rhetorical questions about the meaning of life. However, after a thorough examination of the topic, it appears that the idea of time as the boundary of the universe comes closest to the truth. And what do you think about it? We look forward to seeing you in the comments. And don't forget to subscribe if you haven't done so yet, and we will see you again very soon.